right, so welcome everybody. Today we're going to be talking about right triangles and ratios. As we've been talking about throughout this unit. So here I have drawn us a pair of similar right triangles, and what we have is that this side is similar to this side. So side of length 3 is similar to side of length 9. Side of 5 is similar to the side of length 15, and this side of length 4 is similar to this side of length 12. And so actually what we've learned already is that we can take the ratios. So we can take this 9 over 3, and this actually equals the ratio of 15 over 5, which actually equals the ratio of our remaining two sides, 12 over 4. And actually these all equal the same constant 3, and this constant 3 is like our scaling factor to take us from our first triangle to our second triangle. But there's something more interesting at play here. So if we just look at one pair, for example, we have that 9/3 equals 15/5, and we multiply each side by 3. 9 should equal 15 times 3 all over 5. Then we divide each side by 15. Okay. We actually come up with 9 over 15 has to be equal to 3 over 5. Now, the reason that this result is interesting for us is because if we go back and contextualize this to our triangles, right, what we actually end up is that this side divided by this side, so the ratio of these two sides is equal to the ratio of these two sides on these triangles. We can also take another pair. For example, we'll look at 15/5 and 12/4. Okay, and we can come up with the same sort of thing, and in the end our result is actually going to be 15 over 12 is equal to 5 over 4. So once again, we found this new sort of relation of two sides in our triangle. So like this ratio of this side divided by this side is equal to the ratio of this side divided by this side. Interesting. Now we have one more pair to look at, 9/3 and 12/4. So 9 divided by 3 equals 12 over 4. Again, we can go through these steps that we saw here, and eventually our result is going to be that 9 over 12 is equal to 3 over 4. Okay, and similar to the other two things we've talked about, this represents the ratio of two sides within our triangle. It's this side and this side for our big triangle, and this side and this side for our small triangle. Now I know what you may be thinking. You're not convinced. I drew this triangle myself. Of course I knew it was going to work out like this. So what I did is I pulled a triangle that you guys have submitted through your work, and we're going to look and explore these ratios again and see if we get the same results. So, let's see our similar sides. We have 12 here, 6 here, 20 here, 10 here, 16 here, 8 here. So what we're saying is that 6 over 12 equals 10 over 20, which equals 8 over 16, which all equals the ratio between these two triangles, which we can see is 1 over 2. Okay, so again, we look at some pairs here. We see that 6/12 should equal 10/20. 10/20, sorry. So 6 should equal 10 times 12 divided by 20. All right, dividing by 10, we again see that 6/10 should equal 12/20. Okay, now what does this mean in the context of our triangles? Well, 6/10 is this side divided by this side, and 12/20 is this side divided by this side. So again, we see that these ratios within our triangles remain the same. And I assure you, if we pick the other pairs, for example, 10 over 20 and 8 over 16, we end up with the result that 10 over 8 has to equal 20 over 16. Okay, in other words, this ratio in this triangle has to equal this ratio in this triangle. And then lastly, we see that 6/12 equals 8/16, which means that 6/8 equals 12/16. And once again, we see that it's this side divided by this side and the corresponding side divided by the corresponding side. So these results are maybe not particularly interesting to us now, but as we get into something we call trigonometry, trig for short, like we'll start talking about things like sine and cosine, and we'll see how these ratios are actually very important to us and how this result is kind of amazing.